So let's welcome Cliffano and Mike here on stage.
Thanks for being here for this talk. This is about something we call Swagger AEM. It's an attempt at an OpenAPI specification for, I guess, the various endpoints that AEM provide and we have to work with. My name is Cliffano Subagio. I'm also from yesterday, just minus the hat. And this is Michael Bloch. And we are from Shine Solutions in Australia. And we also work on AEM Open Cloud, which was presented yesterday. We had some early challenges with provisioning AEM for infrastructure projects in the past. So coming back to our first AEM on the cloud project, so it was back with CQ/AEM 5.6, 2013, 2014. And the goal is to have everything infrastructure as code, right? So everything automated, nothing manual. So just move from what used to be provisioned manually on-prem with a thick instruction on how to set up an environment, and that took 3 days. So the idea is to automate the whole thing. Because it's cloud, then it should have auto-provisioning, auto-recoverable capability, and all those kind of things. Now, an interesting thing we found was that AEM tooling was largely Java-focused. So many of the tools that are available, they had to be built using Maven, and a number of tools are Java-related. Now, the problem with that is that we work on client projects, and we were dealing with the SysOps teams, the system engineers. And they were saying, what, you're going to start up JVM just to do that little thing? Or they actually already have their own tool sets, right? Various tools, Puppet, and then along the way, Ansible came about, Chef, SaltStack. So many tools with so many technology stacks that are probably not JVM related. So these were the early challenges we had to deal with. And then we tried to, I guess, get back to the person we worked with back then, and then how do you usually deal with this? And the response that was given to us, oh yeah, use these curl commands. And that was the advice. And we then realized that curl commands were and still are quite popular, right? You can easily find various resources around how to use AEM with curl commands, right? The list just keeps going on and on, right? There are so many lists of various curl commands on how to do X or Y or Z. Yeah, see? It doesn't stop. All right, okay. So this is not exactly an ideal example, but this was given to us back then. So this looks harmless, right? It's just a plain shell script. You execute it, you execute the curl command, you get the result payload, and then you try to check the existence of the word error in the payload. If there's an error, then give a custom exit code. Now, is it really harmless? Yeah, a little bit. So error exit is a bit unreliable when combined with other commands at the higher level. The text checking itself is obviously fragile because not everything is just a payload with error or success, right? It can be an XML, JSON, and everything. You can parse them in shell script, but when you have to unit test your JSON or XML or HTML parsing on shell script, I mean, yeah, good luck with that. It's easier to use other technology stacks, right? The custom exit code is also quite uninformative because what usually happens is that you have to have a dictionary of what does error 123 mean, right? What does error 124 means? And you actually also lose context of what's on the original request and also what's on the response payload, like what's the headers and all those kind of things. And similar to the error, the success is also not meaningful. exit code 0 is just yes and OK. But you often need more information than that. So problems that we encountered with AEM Web API, so we were told it's an API, but I guess they are a set of endpoints. Curl/shell itself is not always available everywhere, right? So there are environments which the tools are not available, or shell itself is not accessible. Some serverless environments do not let you touch shell. There are also this problem with inconsistent payload types, right? Some endpoints respond with JSON, some XML, some have to rely on HTML. Probably they're not the intention, but they were, I guess, quite popular in those, the list of curl commands to use on various blog posts and articles. I've seen people actually trying to sniff what AEM is doing on CRXDE and attempt to simulate that, and that becomes the endpoint that became popular and everyone's using it. So I saw some notes there, so we're all guilty. And there's this unreliable status code as well. So I'm sure this is a problem on the older one, but we had a change password endpoint that responds with status code 200 when there's an error. And we had to, I guess, parse the payload body to identify that, oh, it's actually really an error. And the other thing is the lack of integration with other technology stacks. So again, the various teams we dealt with use different tool sets, and just calling curls all over the places are not going to cut it. So what did we do to solve this problem? We built this thing called Swagger AEM. And what is it? It's basically an API specification for the various popular endpoints that have been currently abused for many years. It is now based on OpenAPI version 3. When we started, it was called Swagger, which then donated to OpenAPI Foundation. And we went through the migration to OpenAPI 2, and now it's OpenAPI 3. And then we also use a tool called OpenAPI Generator. So this tool consumes the specification for those endpoints and then generate API clients. And the API clients they are generated, they cover 30 plus languages. So Python, the popular ones, Python, Ruby, Rust, .NET, Golang, many other tools. So there are lots and lots of them. Here's an example of the OpenAPI specification. So at the top in the header section, you have some metadata, the usual version number, description, contact details, those kind of things. And at the body, it has a property called paths. So this is where the infamous endpoints are captured. So for example, here is, so the operation is a post method against a package service that, I guess, responds in JSON. And you can define the parameters and define how the response body is meant to be looking like. And you can also tag this operation. So that's just a way, if you have a large OpenAPI specification and you want to slice it in different parts of it, then you can tag the endpoints. Now, what's the sequence of the client's generation? So we start with the OpenAPI specification, and then it is used to generate a library. So the one, for example, here is called Swagger_AEM, which is a Ruby API client. And this Ruby API client is obviously based on the endpoint. We also introduced another layer called Ruby_AEM. So it's a similar API client, but instead of endpoint based, it is designed to be resource specific. And other than the Ruby API client, there is also the Python API client, Node.js, Golang, so many others. So they're all generated and available on GitHub. And some of them, the popular ones, are published to the various modules like npmjs.com, PyPy, rubygems.org. And what is Ruby AEM itself? So one reason why we ended up coming up with this layer is because the tool that we had to deal with back then was Puppet. And we want to introduce Puppet modules for dealing with various AEM resources. And one problem was that Puppet's design is resource-oriented. So instead of dealing with call these endpoints, call that endpoints, it's more about, it's not procedural. So it's more, ensure that this resource is available. So for example, if you have an AEM package, then it's more like ensure that the AEM instance has this package with this name of this version. So if it already exists, you can choose to not do anything, or you can choose to override it. So that's why we introduced with this, can come out with this layer. So it's a further abstraction from the endpoints-based approach. Because it's written in Ruby and all those kind of things, then it's easier to introduce the error and response objects. Here's an example of how the result handling is done in the Ruby AEM layer. So at the top line there, it creates a package resource. So you just call aem.package and give it a group, a name, and a version. And then you can specify some options. In this case, the example is you can set force to true. And then you can apply actions against the package, right? You can upload a package. So it's also possible to install a package, uninstall a package, and so on and so forth. You can just give it a directory where you want to put the physical locations, and it will then apply the actions against the package into your AEM. Now, for the result itself, other than the message, it also keeps the response body. So this is where you can still inspect the original status code, the body payload, and all the headers. Similar to the result handling, you can also do the same thing with error handling. So it allows you the ability to at least trap the error. If there is any error, then you get an error object, which you can then inspect to get the response payload as well. What else can Swagger AEM and Ruby AEM do? So it does replication, various replication agents, packages, user groups, they're all resources, certificates, trust stores, key stores, resource readiness checks, attempt to just check the status of AEM. If a package is uploaded, is it uploaded, right? And obviously the use case could be a lot, and there will be so many more APIs that AEM can do, but our scope was based on that infrastructure as code approach, but the OpenAPI specification can just handle more endpoints. So what we learned from this is that there is a pattern. There are some endpoints, and you can introduce specification, and then you allow the integration to other technology stacks to provision AEM. So that's where we also introduce this thing called Swagger AEM OSGI. I'm going to pass it to Michael now to introduce Swagger AEM OSGI.
Yes. Thank you, Cliff. So we also built Swagger AEM OSGI. We introduced Swagger AEM OSGI mainly to reduce the complexity of the communication flow across several teams and to solve some business problems. So this is an example of the communication flow between the system engineering team and the AEM developer team to create an AEM content package for configuring SAML on the AEM instance. So the communication flow is basically we have the system engineering telling the AEM developer, can you please create a new content package to update the SAML configuration? Then the AEM developer are replying with more questions about, can you please provide us more information regarding the configuration parameters. Then the system engineering playing the ball back, providing the configuration parameters. And the AEM developers, they are generating the AEM content package, which includes the SAML configuration. And the system engineering team now tests this package, and boom, surprise, package is not working, SAML is not configured. We see this as an issue, and we see that this can be solved quite easily. But how? So yeah, let's use a curl command to configure SAML on AEM. Yeah. So there's not much to say about it. It's awful. It's very difficult to maintain, especially because there are several parameter types. We have booleans, we have arrays, we have string, and we have numbers. So how can we do it better? So Swagger AEM OSGI comes into the game here. So Swagger AEM OSGI is the API specification for the AEM OSGI configuration. we are basically converting the AEM OSGI configuration from the configuration admin service into over 71,000 lines of OpenAPI's version 3 specification. And we counted it. We generated over 30 clients, API clients, which contains more than 12 million lines of code. That's nothing a human can do, so therefore we need robots to do that. And keep in mind, we tested it. We have to regenerate each time the OpenAPI spec for each AEM version, because with each AEM version, new config parameters are getting introduced and some old ones are getting removed from AEM. So how does the API client generation looks like? We have a tool called OpenAPI Spec Generator, which connects to the configuration admin service and scraping all the configuration node which exists on the configuration admin service and generates the OpenAPI specification out of it. Then we are using the OpenAPI generator to create the Swagger AEM OSGI client in more than 30 coding languages. This is an example of the OSGI configuration node. So that's the adaptive form and interactive communication web channel configuration. So we see here that we have several types of configuration parameters. We have booleans, we have numbers, and we even have a drop-down parameter type here. Translated this into an OpenAPI specification looks very much like this. We have our path declaration up here, then we have the HTTP action, and then we have all the parameters this configuration node supports. We found out that every configuration node expects certain common parameters. Those are parameters like post, apply, and property list. I omitted them here and just displayed the parameter nodes which are very unique to this configuration node. On the right pane, we see the response. We are defining the response codes we are expecting from this HTTP action for this particular path. So we are defining a 200 response code, 302, and a default one. What I want to highlight here is this. So we are not even describing the response code, we are also describing the content we are expecting for this particular response code, which is very powerful because it means we are not only getting the response code and the response message when we are executing this action, we are also getting all informations which are behind that configuration nodes, which includes, as an example, the property value. We also can retrieve its mandatory or optional value, and we also get a parameter to determine was the property set or is it unset, which can be used to check if the configuration node was configured or not. Converted this into Ruby API client code looks very much like this. So a lot of lines of code, again, nothing a human can do or would do, because there are like, I think, thousands of configuration nodes. Demo time. So what we are going to demonstrate you is, firstly, how we generate the OpenAPI spec file with over 71,000 lines of OpenAPI spec, and then how we use a provisioning tool, in that case it will be Puppet, to use the Swagger AEM OSGI API client to configure and enable SAML on AEM. Perfect. So, yes. Firstly, I'm going to show you how we generate the OpenAPI spec. Can you see everything? Perfect. So this is the command we are running. So the first few parameters are environment variables to define the AEM node we want to connect to. Then we are calling the tool, and we are passing in a template API YAML file and telling the tool where we want to have the output file saved to. So if you go back to the atom, we see this green file, which just got generated. And we see this is the OpenAPI spec file, which just got generated. And if we go to the bottom, here we see like over 71,000 lines of API specification. So now we can use the OpenAPI generator to create a API tool in our most favorite coding language, which is in that case Ruby, and use our most favorite provisioning tool, which is in that case Puppet, and configure using this, and now we are using the Swagger AEM OSGI API client to configure SAML. Again, the first few parameters up here are configuration environment variables to define the AEM node, and then we are passing all the parameters this configuration node expects from us, and then further down it's done. And I want to highlight this. So this is a check we implemented to check if one of those required parameters are actually set or not set. If it's not set, then it's a retry. It checks attempts 1, 2, 3 until it's timed out after, I guess, 60 retries. And if we go now to AEM, there you go. We see, no. So we see that SAML is configured, and we are getting redirected to our SAML provider, which is in that case Google. So once we are logged in, and luckily we are not using default passwords, and we are using two-factor authentication. We are getting logged in to AEM by using the API client to configure it. Same applies for if you want to delete a configuration node. Shouldn't take that long. Yep. Boom. Configuration node was deleted on AEM. Now we can sign out, and we are getting back to the AEM login page. So resume. So how does the code flow looks like? On top, we have our most favorite provisioning tool, automation tool, which we use Puppet AEM resources, which is a part of the AEM Open Cloud solution. Puppet AEM resources passes all the parameters for this configuration node to the Ruby AEM library, which then prepares the payload for the Swagger AEM OSGI API client. And the Swagger AEM OSGI client is connecting to AEM and passing all the configuration parameters to AEM and configures the OSGI configuration. So now we have this API client, which makes managing AEM so easy now. And we can now look into different use cases to manage AEM. So therefore, we are going to present you how we can use this API client, which is Node.js, to deploy to install a package on AEM by using your voice and the IoT device or your smartphone. Oh, yes. So we are connected. So this is the AEM instance where we are going to install this AEM Hello World content package using your voice. Don't be confused. We set an alias to this to the package name, which is ABC. Yes. Go ahead.
Okay. So just to demonstrate an alternative use case. So for the SAML provisioning example, we use Ruby API client. For this one, we generated the Node.js client, and the idea is that we want to install that package at the top. Well, if it's going to fail, I'm going to blame the internet here. Oops.
I found a few.
Oops. Talk to Convo AEM.
Okay, let's get the test version of Convo AEM. G'day mates at AdaptTo Conference 2019, I am AEM. How can I help you?
Install package ABC.
ABC has been installed.
So let's refresh that screen, and hopefully the
Yes.
internet works.
Sorry, I do not understand what you said.
Oh, sorry.
Say that again.
Yeah, but we
Hey,
see
it's installed.
package was installed.
Yeah, so we have to use an alias ABC just because that is called AEM Hello World content. And I grew up in several countries, and that messed up my accent. So just to show the idea, right? Back to you, Michael.
Yes, thank you, Cliff. So to go a step further, we even going to present you that it's multilingual possible. So I need to go to my Chrome browser, and now we can even talk in German to AEM by installing the same package on AEM. So let's try it. Oh, no, again. Mit Convo AEM sprechen.
Gerne. Starten wir die Testversion von Convo AEM. Guten Tag adaptTo Konferenz 2019, ich bin AEM.
Installiere Paket ABC.
Packet ABC wurde installiert.
And that's all. And now let's refresh the page again just to make sure it's installed. Yeah, installed. So yeah, so how does the data flow looks like in this example? So we have our IoT device, which we are talking to. This IoT device connects to the Dialogflow. Dialogflow is responsible for translating the voice into words and generates a payload, which then gets forwarded to the Google Cloud function. The Google Cloud function is preparing the payload to pass it to the Node.js Swagger AEM client, and the Node.js Swagger AEM client connects then to the AEM instance and tells the AEM instance to install the package on AEM. And then AEM responds with a 200 response code. The Swagger AEM client receives the 200 response code, knows 200 means package has been successfully been installed, prepares a payload for Dialogflow, and Dialogflow then forwards the payload to the IoT device, and the IoT device therefore receives the payload and translate the text to speakable to speech. So in conclusion, we can use API clients to open up a new way of managing AEM and start thinking outside the box and find other ways to manage and to use AEM in the future. So what have we learned today? We've learned that API specification enables API clients. API clients enable a richer integration into the AEM application. And AEM provisioning doesn't have to be Java focused. We can use now any other DevOps tools or automation tool, provisioning tool to manage and provision AEM. And there are lots we need to integrate. So most important of all, this is a part of AEM Open Cloud, of the AEM Open Cloud solution. AEM Open Cloud solution is open source. So feel free, you are very welcome to join this effort, to join the ride, and feel free to contribute to to benefit the wider AEM community. Contact, like Cliff already said yesterday, contact us on GitHub, LinkedIn, or however. Thank you for listening, and any questions?
Everyone's too eager
No.
for coffee.
Okay.
So, thank you for your talk.
No worries.
Thank you.